Welcome to Evolution Impossible, a production of 3ABN Australia Television. Our host is Dr. Sven Estring with special guest Dr. John Ashton and our panel.
Welcome back to Evolution Impossible. I am Dr. Sven Estring and we're exploring Darwin's theory of evolution and considering whether the evidence supports his idea. For our discussion today, I have Justin Terosian with us. Thank you for being here. Harley Southwell, good to have you back on the set with us. And of course, Jean-Ray Brou, good to have you here as well. And of course, we have our very own resident scientist, Dr. John Ashton. Good to have you here as well. Now, John, we've been really glad how patient and accommodating you've been for all of our questions. So thank you very much for that. One of the big things that evolution needs is time, and lots of it. That's why Charles Darwin was so intrigued and attracted to Charles Lyell's hypothesis that geology points to long ages. But do geological processes really lead us to an old Earth? That's a topic for today's discussion. And this is a topic that you, Harley, have explored yourself. So you had parents who were talking to you about a young Earth, but then you also were learning about old Earth hypothesis as well. So share with us, what was your journey like in this area?
Yeah, well, in high school, I took on an elective in Earth and Environmental Science because it's something I'm always interested in, studying terrain and rocks and things like that. And so as I was studying through that, obviously, you encounter radiometric dating, long Earth, erosion, fossils, and all those ideas as well. And so it was something that I had to really sit down and decide, what am I going to believe for myself? Is it something that's just going to be what I believe what my parents have taught me, or what scientists are saying? And I really studied out myself and came to my own personal conclusion, which is that that the Earth is young. And I was happy with believing in that after reading a wide variety of literature and online articles.
And Harley, that's a very surprising conclusion to draw, considering the science and what scientists tell us. So, John, we want to know, is there any evidence for what Harley is talking about? For within the Earth, is there any evidence for a young age for the Earth?
Well, yeah, sure. If we want to look for that, I guess initially, though, why people look at an old Earth is probably on the basis of radiometric dating. So we're told that the Earth's 4.5 billion years old for a start, and the continents formed, 2.5 billion years ago, 3 billion years ago, and this sort of thing. So this seemed planned at a fairly early age, so I guess that underpins it. So when we say, well, what is the evidence for a young Earth and for a young solar system? Well, this is probably a little bit outside our topic, but one classic area is the strength of the Earth's magnetic field. And so we know that the Earth's magnetic field has been decaying. It's decaying exponentially. We know it's decayed about 10% in the last 150 years, so we have quite accurate measurements of the Earth's magnetic field. Now, if we go back in history to millions of years, the Earth's magnetic field is going to be so strong that the temperature in the Earth would not permit life at that time anyway. So there are a lot of...
What about these ideas about the reversals and the polarity with the magnetic field? How does that play into that magnetic field of the Earth?
Right, so these reversals in crystals, in magnetic crystals that are observed in lava, these reversals that have occurred there, they are very characteristic of probably the time when the mountain ranges were pushed up, because obviously there was some violent disruption of the surface of the Earth. And in a way it sort of fits in with George Dodwell's observations that have been recorded, that maybe it gives some substance to them. I'm not sure. I'm not going to go down that track. But obviously it fits that during the flood there was a major catastrophic event and the Earth was probably violently shaken in some way, and that resulted, as we know, in the mountain ranges pushed up, and at that time obviously the core and whatever's responsible for the Earth's magnetic field, the dynamo effect, was also reversed at that time. But all these things again, I think, point to the fact that they're examples that the Earth must be young. There's other examples too out in the solar system that our solar system itself must be young. And that's on the basis of the temperature that we measure in some of the, now that we've reached the outer regions of the solar system, looking at some of the moons that are around some of these outer planets like Uranus and Neptune. I can't remember them exactly off the cuff, but we know that some of them still have, you know, molten lava. They're very at a much higher temperature than they should be if they were really as billions of years old like the solar system is supposed to be. So there's so much evidence everywhere we look, even within the solar system, that points to the Earth being very young and the solar system being very young itself.
That's amazing. And you also mentioned in this chapter in your book that there's evidence in the surface of the Earth in terms of the sedimentary layers and erosion rates. So can you walk us through that concept as well?
Well, look, erosion rates, in my view, are the death knell to the long age hypothesis. Because, look, if we look at if we take, say, the classic example that is, especially American textbooks, and most of us have seen pictures of the Grand Canyon, and we see those sediments that are, 1.5 kilometres deep or thereabouts over there, and we say, well, look, for this amount of material to be eroded away, it's taken really slow over a really long period of time. Well, actually, let's have a look at the data. Now, the geographers have collected data on the amount of material carried by the Colorado River at the present time. And we know that it's roughly the whole area, that whole plateau there in Arizona is eroding away at about 100 millimetres per 1,000 years. Now that doesn't sound like much. 100 millimetres, 4 inches, 1,000 years, that's not much. But hang on, that means that if it's 1.5 kilometres high, in 15, 20 million years, the whole lot should have eroded away. That is, the whole countryside should have eroded away in that time. And we know this from geography data from around the world. The average rate that geographers use for erosion of the continents, and some are much higher, particularly in high rainfall areas, is about 60 millimetres per 1,000 years. As I said, it doesn't sound like much. But when you consider the average height of the US continent is only about 650 metres, what it means is that the continents are going to erode away in less than 10 million years. And so if the continents can erode away in less than 10 million years, how can these sediments be hundreds of millions of years old? How can the continents be billions of years old? It just doesn't fit. And that's data that we measure today, reproducibly, reported in the secular scientific journals from geographers all over the world, similar values. So you can get tables of the erosion rates that are occurring. Got a lot of accurate data on this now. The surface of the Earth, if it was really hundreds of millions of years old, would have eroded away. It wouldn't be there. And so this is a powerful death knell to these days. Now, this raises an important question because we radiometrically date all these ages. It raises serious questions about radiometric dating that we can talk about sometime. But this is a very, very important area that we look at, the rate of erosion of these materials is something we can measure. Now, the other thing that we can look at too is the rate at which sediments are being deposited in the sea and this sort of thing.
So erosion would mean that it's going from the land being eroded into the sea, yep.
Yes. So one of the things we can say is, well, I think the top layer there at the Grand Canyon, using the Grand Canyon example, is about... I think the top sediments are dated at about, 200 million years or something like that. So one of the arguments is, well, maybe there were other sediments on top. Well, at the erosion rates, if you work it out, the sediments would have to be about, 3 times the height of Mount Everest on top again to provide enough overburden to erode away to last that long. So we get into all these ridiculous scenarios if we try to have that the continents are really thousands of millions of years old. It just doesn't work on the basis of erosion rates. But there's more, because we know in the past the rainfall was much higher than it is today.
So
there was a lot of
how do we-
dense vegetation.
So how do we know that the rainfall was higher?
Because we have the remains of vegetation and this sort of thing, and forests and this sort of thing that lived in these areas in the past. And all over the world, yeah.
Sorry, just before we get too far into the sedimentary layers and erosion, I just want to go back to what you said before about the young universe and young Earth. Is there any evidence that the universe and the Earth were created at different times, so that the Earth is maybe younger or so, because we've got all these stars that are millions of light years away? How do we see those lights if they were created at the same time? What are your thoughts?
Right, okay. Well, this raises a question that probably deserves another whole session. But very quickly, we need to understand about time. And there are a number of factors that affect time. So as a satellite, if we have the satellites around the Earth, as they travel around the Earth, because they travel fast, time slows down on those satellites, right? So I forget, off the cuff how far it slows down. It's probably about 5 or 6 microseconds per day that they time. So if we had an atomic clock, so that's uses the same rate of decay as radiometric dating, right? So if we had an atomic clock on that satellite, it would slow down and be running slower compared to Earth clock by about 5 microseconds per day.
Wow.
But on the other hand, it's a lot further away from the Earth's gravitational field. Now, gravitation or fields slow down time. So that means that now our satellite clocks are running faster due to the fact that they're further away up there.
Wow.
And so they actually run faster. A typical communication satellite, like you use, say, on your GPS and so forth, will run something like about 40 microseconds per day faster because it's out there. So in actual fact, engineers, again, do these corrections and they subtract the 5 or 6 from the 40 and they correct by about whatever it is, 35. I'm running from memory here, but it's roughly these sort of figures. And if they didn't correct for those sort of values, your GPS would accumulate errors of about 400 metres per day.
Wow.
Right?
So you'd be lost without...
We'd be lost
literally.
But what I think we need to understand is a lot of people don't understand a lot about time. Now, when we talk about, again, if God created the universe and the universe was expanded out from where the Earth is, right? So we talk about the Earth was created, and then it talks about the stars are created. And I know for a lot of listeners this is going to blow your mind because you're not taught about these things. But this is the real science. This is real theoretical science. If we look at how the Earth, the Bible talks about how God stretched out the heavens. So if there's an intense gravitational field here, clocks on Earth here are going to be very slow. Whereas as God's stretching it out here, those clocks are running relative to Earth time very, very fast. And so this is one of the problems. The other thing where people don't realise is that when we talk about the speed of light, right, and these stars are millions of light years away, we are talking about the two-way speed of light. Because it's impossible for us to measure the one-way speed of light.
Yeah.
We don't know what the one-way speed of light is.
Okay.
And this is the problem of synchronicity. And so we work on it is the two-way speed of light, the average of the two-way speed of light that we work on. It is theoretically possible, it doesn't violate any laws of physics for light to reach us instantaneously from the stars. And to me, this will help. See, what happens is there's the Reichenbach equation of synchronicity, and Einstein just happened to choose the epsilon value of 0.5. And it was a random choice. It wasn't based on any scientific evidence. It was just a random choice. And the epsilon value can theoretically range anywhere from 0 to 1. If we choose the value 1, which is a logical one, we have instantaneous light travel.
Wow.
It's pretty cool. And this makes a lot of sense. And I've always wondered this, even before I really got involved in creation research, as I was studying physics at university years ago. the thing is that why are we seeing the astronomical events taking place on our timescale? It's always fascinating me. It's as if it's all set up for us to observe on our timescale. And why would God create things where we're looking at billions of years in the past? It creates a whole lot of problems. You know, in terms of time.
Is it possible though that like God created the universe a long time ago and has like a lot of fun with that, and then also later on he decides, oh, there's another little spot over here, I'm going to create something more, and he finds like a little empty, crusty rock, and just like, oh yeah, I'll make this into it's nothing, so I'll make it into something. Is that another possible theory that would kind of like fit with?
Well, how could we know? The problem with that is it doesn't really fit with the Bible account, and you can have any sort of other theory. So John Wheeler got his PhD in the early 50s for the multiverse theory, the multi-universe theory. You know, so you can have all sorts of theories. We come back to what can we know, and so there's a number of things that we can know. How can we know the past? We can only know the past if there was some observer that can tell us the past, or there was some observer that made a record of the past. Time's a very interesting thing, as I said. You know, time is affected by so many things, and this whole concept of our understanding of time is one that, you know, we can talk about perhaps in a later session in a little bit more detail. But sure, you can have that scenario. And that's as far as it goes. But in terms of data, we have a Bible record where we know the Bible account fits accurately historically, and also the Bible has prophecies in it where God reveals that he knows the future. Now, this is a very important aspect that we can discuss sometime too. And on this basis, it gives us reason to trust the Bible. Or if we have a look at it, we can say, well, what's the probability that the Bible is true or not true, right? So the Bible is either true or it's not true. And so we look at the probability. Now, when we look at the historical evidence lines up, when we look at the prophetic evidence that lines up, there's about 750 prophecies listed in the Encyclopedia of Bible Prophecy that was published by Princeton University Press. When we look at this sort of data, that most of those have been fulfilled, and the ones that haven't are either future or, you know, conditional and so forth. Then if we looked at our odds, we got very, very high odds that what the Bible says is true. And it's sort of like, well, if you were flying in a plane and someone told you, look, I work as an engineer and, you know, the engines in these planes are due for a major breakdown at so many hours, and this plane's, you know, 1 hour before that, would you hop in the plane? You know, it's you've got good data up to this time. We know all these engines fail after so many hours. Well, we don't know for sure whether it is going to fail. We could be lucky. But this is exactly what we face with the Bible. And this gets me why young people aren't being taught about the Bible today. We have so much scientific evidence supporting the Bible as a historical account of God's history with man, and young people aren't being told about. And when we look at the science, when we look at the mathematical probability, the probability that the Bible is true and the account about God is correct is very high. And
talking about the evidence, talking about the erosion rates and the sedimentation, it's a fascinating area which really supports faith in the Bible. And one of the questions I have is, you've got these erosion rates, but isn't it possible that the deposition rates, the deposits, kind of match the erosion rates, and so we kind of have this equilibrium, so the Earth could be a lot older than what the erosion rates may tell us?
Okay, so the surface of the Earth is replenished with volcanic material.
Yes.
Okay, so, and when we look, we know at the present time the rate at which new volcanic material is being poured out on the surface of the Earth. And I forget the actual figure what it is, it's, you know, 3 or 4 or 5 cubic kilometres per year. And so if we look at now all the known volcanic outputs onto the surface of the Earth that we can measure and observe today, all those would occur in, I think from memory, just over 30 million years. So at the current rate. But of course, I know you walk just down to the beach here and there's all these dikes that come through and you see the sills that have come through. There's a lot of volcanic activity in this area and just about everywhere you go that is now dormant, thankfully. And so we know that the volcanic activity in the past was much more rapidly. So again, even if we look from the volcanic intrusion effect, the amount of volcanic material coming on the surface of the Earth's surface can't be hundreds of millions of years old.
Very interesting.
It just doesn't fit. It all comes back to the biblical type picture timeline.
And not only do we have the erosion rates, but we have the matching mutation rate as well. And I'm just wondering if there's anybody else who has some questions for John on these topics.
I had a question about the mutation rates of, the human DNA. And according to evolutionary theory, evolution can take place because of genetic mutations that are positive and a positive thing for humanity. But you mentioned in your book, in this chapter, about how the amount of genetic mutations in human DNA that would have taken place in that long of a time, as evolutionary theorists suggest, would actually lead to human life being extinct. And so the very thing that evolutionary theory depends upon, genetic mutations, seems to be the very thing or another thing that disproves it as being true. I just wondered if you might be able to comment.
Yes, this has been discussed in the scientific literature, and it's something that's blown the minds, I know, of a lot of evolutionists and people that believe in these long ages, because we now have very good data on genomic decay, the rate at which we're accumulating mutations, particularly in mitochondrial DNA. These are reported in the top journals like Nature and so forth. And so we now know, and if we extrapolate back, sure, life on Earth cannot be more than 10, 20,000 years old, best, or maybe 100,000 years at best, because the amount of mutations would accumulate if life was older than that. Like, for example, they claim, humans started about 2 million years ago, sort of began to separate from apes about that time and so forth. And so they, somewhere between 1 and 2 million years ago. Well, during that time, we would have accumulated so many mutations that, our bodies would have broken down. There'd be so much disorder. So you're spot on. So this is just one of so many things that says evolution is impossible and didn't happen.
So why would a God create, though, an Earth that decays and a genome that decays and so forth?
Well, our understanding is, of course, that as revealed in the Bible, that this decay was a result of disobedience or a breakdown of following God's perfect laws in the beginning. So God set up a system that was perfect, and the first humans there sort of chose to violate that. And I guess this brings into a whole other concept of the supernatural. And we a lot of people just believe in the physical world here, but of course the Bible reveals that there is a spiritual world. There's spiritual creatures, angels, demons, and so forth. A lot of people don't want to accept that there are demons and this sort of thing. The Bible clearly points to this, and I think there's a lot of evidence for this, particularly when we go into more primitive societies. And so I think it's very clear that people can see there's a conflict between good and evil, and there's a battle going on. And as a result of that, of course, our bodies no longer are perfect. They're subject to this decay. And I think God had to do that because it wasn't good for evil to just continue to go on. We see the effects of evil in our world today. It's terrible. And I often think, why are people developing all these weapons and then they're firing rockets and bullets and they're blowing up people that was somebody's little baby that grew up and they loved, and why are we destroying each other? And there's so much greed and hate. And we can see all these bad things, and yet we see the love of a newly married couple. We see the love of a parent to a child. We see the innocence of young children and so forth. And there's so much good. We see people rallying together with the bushfires and when national tragedies happening. But we see this conflict between good and evil. You know, we have the bushfires, the firemen are there fighting, and there's also people coming in and looting. You know? So
it's very
it
interesting.
explains a lot, the Bible.
It's very interesting you talk about that conflict between good and evil. And I guess a question I have is, you know, the theory of evolution, you know, where does that kind of fit into this conflict between good and evil? Have you reflected on that question?
Well, you know, other people have too, and sort of have linked, well, you know, it's survival of the fittest. And also the whole concept of evolution seems to have underpinned a number of atheist regimes that have certainly committed a lot of really bad things. And while people say, oh, well, you know, hang on, it's not atheism that's bad, but I think really, and the argument has been raised, if we're not accountable to a creator God, why should we be good if we know we can get away with it? It raises that question there, and I don't think there's an answer. And, you know, atheists say, well, you know, I can choose to be moral and all this sort of thing. And that's right, they can. But again, one questions, well, where does that choice come from? And maybe there is something more. See, one of the things that evolution doesn't explain is the concept of consciousness and the mind and who we are as being non-material. And I could talk for that for a while, but you know, we're getting off topic here of erosion rates. I think the bottom line is that erosion rates, deposition rates, when we look at them, they all point to a young Earth.
Yes.
And the other important factor is that they raise serious questions about the radiometric dating results that we get that point to this deposit being 100 million years old, this deposit being 300 million years old, and so forth. It doesn't work in terms of erosion rates. So therefore, there's got to be something fundamentally wrong with radiometric dating. And yet radiometric dating is considered as the be-all and end-all, the rock-solid data sort of thing, age method. That's
maybe if we just dive into this topic, into the sea, what about marine sedimentation kind of layers, and how thick are the deposits down there?
Well, that's right. Again, if the Earth was hundreds of millions of years old, those deposits would be much, much thicker than we calculate them to be. At the current erosion rates, all the deposits that we measure at the depth of the sea, they're only about 450 metres deep, they would deposit in about 15 million years. So again, no matter where we look at, it's all pointing to a young Earth. Yeah.
It's amazing. This has been a very fascinating topic, and I'm sure that you've enjoyed following along our discussion. If you'd like to learn more about the idea that our planet may not be old enough to give sufficient time for evolution to have occurred, you want to get Dr. John Ashton's book, Evolution Impossible. You can go to your favourite online bookstore anywhere around the world and just click on it and get it right where you are. It is quite astonishing that sedimentation and erosion rates point to a young Earth. But as we talked about, what about radiometric dating methods? Aren't those methods absolutely rock solid? Not only here on Earth, but also in the universe as well. That's a topic for our next episode, and it's definitely not a discussion to miss at all. So we really invite you to come and join with us again. And if you want to catch up on previous episodes, just go to our website, 3abnaustralia.org.au. We look forward to you joining us again next time.
Thank you for joining us on Evolution Impossible, a production of 3ABN Australia Television. If you have any comments or questions, send an email to radio@3abnaustralia.org.au or call us within Australia on 02 4973 3456. We'd love to hear from you.